everyone. I hope you all are fine. So let us start our today's session. In our today's session, we will study about the type of redox reaction. So as you all know that in the previous session, I have taught that what is the redox reaction? A type of reaction in which oxidation as well as reduction takes place simultaneously. Simultaneously that we have to know. So that means this is a type of redox reaction. So here the different type of reactions that I'm just going to discuss with you. One is to be of combination reaction, a reaction in which two atoms or the molecule combine together to form a product. This is a type of combination reaction. So normally it can be represented as A plus B, that gives a C. So I have picked the one example, like suppose C plus O2, carbon is combining with oxygen, it is forming CO2. So here we will put their oxidation number. Alone element oxidation number will be 0, O2 0, and here oxygen will be -2, and against it its oxidation number will be of +4. So you can see here carbon is going to be oxidized here. Here the oxidation is taking place and oxygen is going to be reduced 0 to -2. So that means the reduction is taking place. The same condition will be there, O2 0, H2 0. This is a peroxide case, so the oxidation state of oxygen will be -1 and hydrogen will be +1. So hydrogen, you can say this is 0 to +1. So that means the oxidation is taking place, and oxygen is 0 to -1. So here the reduction is taking place. So that you can say this combination reaction, it is a type of redox reaction. Another example, we are coming for decomposition, a reaction in which a molecule breaks down to form two or more compounds. So you see here the few examples I have written. Potassium permanganate on heating, that will decompose into potassium magnate plus MnO2 and plus O2. So let us write there the oxidation number. 4 2 are 8 and potassium is +1, so we will get there the 7, and here we will get there 4 2 are 8 and the -2. Actually oxidation number is +1, so +1 into 2, that you have to subtract this 2 from the 8. So we will get there the number 6, and here we will get there magnesium is +2 and oxygen is 0 here. So you see here magnesium, that is going to be +7 to +6. Okay. And the next one, that is going to be +7 to +2. You can say simply. And oxygen, that is -2 to, that is going to be 0. So -2 to 0, that means oxidation is taking place. 7 to 6 and again 7 to 2, that means the reduction is taking place. Okay, so that we have to know that. Now the next type of reaction, this is a displacement reaction, a reaction in which an atom or the ion in a compound is replaced by an atom or the ion of the some other element. So this is a type of displacement reaction. So that can be represented like that, A plus BC. So C will be replaced by the A. So AB will be the new product and C will be replaced. Okay. So that displacement will be of two type, metal displacement or the non-metal displacement. Suppose non-metal is displacing any other element from its salt solution, so that will be of non-metal displacement. If metal is displacing, so it is a type of metal displacement reaction. So you see here, like suppose zinc is displacing copper from its copper solution, so that the oxidation number of zinc will be 0, and copper it is to be of +2, and this is -2, and this will be of +6, and here the copper will be 0, and here oxygen -2, this is +2, and this will be of +6. So you can say here zinc oxidation state, it is going to be 0 to +2, that means the oxidation is taking place, and copper, if you will see, +2 to, that is going to be 0, so that means reduction is taking place. There is no change in the oxidation state of sulfur, you can see here properly. Okay, so now, so I have written here the language for the non-metal displacement also. Okay, now let us talk about the very important reaction. This is the disproportionation reaction. So you see here a reaction in which the same species is simultaneously oxidized as well as reduced is called disproportionation reaction. It means a type of reaction in which a same element, first it will oxidize and after that it will reduce. So here I have written there the few examples for you. Here the oxidation state of oxygen will be 0. Here -2 and it will be of +1, and here -1. This will be the oxidation state of oxygen because this is the case of peroxide, hydrogen peroxide. So you can see here hydrogen that will remain same, +1. So that oxygen, it is going to be -1 to -2. So that means the reduction is taking place. And here if you will observe the oxidation state of oxygen, that is going to be 0. So that means the oxidation is taking place. That you have to know that. Okay. So if we will see here the next reaction, the oxidation state of P4 in the molecular form, that will be of 0. And here you can see here that hydrogen is +1, that is going to be +3. And in that case, if you will find out the oxidation state of phosphorus will come +1 because it is of -2 and hydrogen is +1. So that if you will solve it, that you will get +1. So you can see here the first phosphorus that is going to be oxidized in +3. So that means you can say here the oxidation is taking place. And now in the secondly, you can see that is going to be +1. Okay. So 0 to +1. 0. So -3 oxidation state here we are getting in terms of phosphorus. So here the reduction is taking place. And in that case 0 to +1, that means the oxidation is taking place. Okay. So the next one more example I just want to discuss with you. Like suppose you are having CaCO3 and you are heating it. So what will happen? That will dissociate into CaO plus CO2. So you try to find out. This is +2. This is +4 carbon and this is oxygen -2. This is -2 and this is +2. This is -2 and this will be of +4. There is no change in the oxidation state of a single element. +2, +4, -2, +2, -2, +4, -2. There is no change. So it is not a redox reaction. Okay. And one more example I just want to discuss with you. Like suppose we are having a reaction Na2SO4 sodium sulfate that is reacting with barium chloride and that is forming barium sulfate plus NaCl. So here I have written there the balanced part. If you will write their oxidation number, oxygen will be -2, sulfur will be +6 and sodium will be +1. And here chlorine will be -1, barium will be +2, -2, +6, barium will be +2 and here chlorine -1 and sodium will be +1. So you see here there is no change in the oxidation state of a single element. So this is also not a redox reaction. So here you have to know this reaction is specifically, it's a type of double displacement. So always remember double displacement or double displacement, and the another name of double displacement reaction, it is of precipitation reaction. Not a redox reaction. Okay, so that you have to know that it never be a redox reaction. Okay, I hope you all have got it. That's all for today's session.